second subtopic for the matrices, which is determinant of matrices. At the end of the lesson, the student should be able to find the minus and the cofactor of a matrix, and the student should be able to find the determinant of a matrix. So what is meant by determinant of matrices? The determinant is a useful value that can be computed from the elements of a square matrix. The determinant of a matrix A is denoted by these two forms. Only square matrices possess determinant. For 1 by 1 order matrix, the determinant is equal to the element itself. For example, if you are given the matrix A with the element -3, then the determinant of A is equals to -3. For 2 by 2 order matrix, the determinant of A, which is in the form of A, B, C, D, is defined by determinant of A equals to AD minus BC. For example, if you are given the matrix A, which is consists of the element 7, 5, -1, 9, then the determinant of A is equals to 7 times 9 minus 5 times -1, which is following the formula of AD minus BC, which is will give you the answer is equals to -68. For the 3 by 3 determinants, we will discuss later on. So we're going to proceed to the example 8. For the example 8, you are given two matrices, which is both are in the form of 2 by 2 matrix. So the question asks to find the determinant of A, determinant of B, determinant of AB, and also determinant of BA. So since this is the 2 by 2 matrices, so in order to find out the determinant, you just need to follow this formula, which is you have to compare with the general form of 2 by 2 matrices, which is in the form of A, B, C, D. So to find the determinant, you just need to calculate for AD minus BC. So we are going to solve for this question. So to find the determinant of A, so you just need to identify the value of A, B, and C. So and then you just need to calculate. So AD is the first element of the matrix A. So A will multiply with D minus with B multiply with C. So you just need follow through the given formula, which is 2 times 8 minus 5 times 3. So that will give you 1. Next, to find the determinant of B, it's the same process with the way we find out the determinant of A, which is follow through the formula of AD minus BC. So means that determinant of B is equals to 3 multiplied with 2 minus 5 multiplied with 2. So and you just need to calculate to get the final answer, which is you will get -4 as the final answer. And then next, we are going to continue with determinant of AB. So to find out the determinant of AB, you need to calculate the multiplication of matrix A between matrix A and matrix B first, which is matrix A is 2, 5, 3, 8 multiply with B 3, 2, 5, 2. So just follow through the process of multiplying the two matrices as what we have discussed before this. So you will get the answer for multiplication of these matrices as 31, 14, 49, and 22. So, and then we continue with finding its determinant. So, since this is the 2 by 2 matrices, so you just need to compare, use the same process with what we have done for the matrix A and matrix B. So, it means that if we follow through the formula of AD minus BC, so we get 31 multiplied with 22 minus 14 multiplied with 49. So that will give you -4 as a final answer. And lastly, the question asks for the determinant of BA. So you have to calculate first the multiplication between these two matrices, which is matrix A, matrix B multiplied with matrix A. So calculate these two things, so you will get 12, 31, 16, 41. So that means in order to find out the determinant of BA is equals to 12 times 41 minus 31. 12 times 41 minus 31 times 16. That will give you -4. For the alternative ways, how to find the determinant of, there is an alternative way how to find out the determinant of AB and determinant of BA without multiplying the matrices itself. You can refer the properties of determinant, which is will be discussed afterwards. Next, we are going to continue with finding the determinant of 3 by 3 matrices. Before we find out the determinant of 3 by 3 matrices, there are a few things that we need to discuss, which is about minor. You need to know how to find the minor and cofactor first before we continue with finding the determinants. So what is minor? So minor basically is the determinant. The notation for minor, usually we use the M, which is stand for minor. And there is a IJ as a subscript here, which is referring to the location of the entries that we need to find out the minor itself. Is the determinant, minor is the determinant of the submatrix form by deleting the ith row and jth columns. So for example, if you are given this 3 by 3 matrix, which is the given matrix A is, the element is 2, -4, -3, -2, 0, 4, 4, 3, -3. Then if the question asks to find the minor of 1, 1. Okay, minor 1, 1. So what does it mean by minor 1, 1? So 1, 1 itself is referring to the first row and the first column. The first value stands for the location of the row, the second value for the locations of columns. So means that after you identify which row or which column, so you have to delete that row and that column. So after you delete that row and that one of the row and the column, you will notice that the remaining elements here, there will just only 4 elements left, which is this will form the 2 by 2 matrix. So since the minor itself, the definition of minor itself is a determinant. The definition of minor is the determinant. So means that after we get this 2 by 2 matrix, after we delete the row and the column, you need to find out that determinant. So means that if we proceed this step, the remaining element or entry here, we just copy down with the notation determinants. This is the notation of determinant. So, and then you have to finish it by calculate its determinant. So, by using AD minus BC, you will get negative 12 as the final answer. The same thing goes for the minor 3, 2. So, if the question asks for the minor 3, 2, means that you need to delete the third row and the second column. So, you just need to delete the third row and the second column. So, the remaining elements or the remaining entries, you have to find out its determinants, which is we give you 4. That is what is meant by minor. So, we proceed with the cofactor. So, the notation for cofactor is by using C, which is referring to the cofactor itself. Ij is referring to the numbers of rows and column, is obtained by multiplying the minor with negative 1 to the power of I plus j, which is Cij is equals to negative 1 to the power of I plus j multiply with minor. So, in order to find out the cofactor, you have to find out the minor. You need to know how to find the minor. So, the minor itself is what we have discussed before this. Okay, for example, if the question asks to find the cofactor of 1, 1. So, cofactor of 1, 1 means that the cofactor for the first for the entries of the first row and the first column. So, what you need to do is just multiply negative 1 to the power of I plus j. So, the value of the first, I is the value of the first part. J is the value for the second part. So, I plus j means that 1 plus 1 multiply with minor. So, how to get the minor? Since we already calculate for the minor 1, 1 from the previous part. So, you just need to copy down the answer for this one. Just copy down and you just need to multiply with negative 1 power of 1 plus 1. That will give you negative 12. Okay, and then we continue with finding the determinant of matrix A of 3 by 3. So basically, to find the determinant of matrix A is the expansion of row or column. You can choose any rows or any column that you prefer the most, which is that will give you 6 choices. Whether you can choose the first row, second row, third row. Right? So you have 3 options of row, first, second, third, and also you can choose any columns. So the choosing of any rows or any column, that will give you the same answer. You will get the same answer. So after you choose which row or which row or which column that you prefer, okay, and then you just need to continue with your calculation, which is the determinant of A is equals to the A. A is the entries. The entries means that the value of the entries for the given matrix. So the entries itself. So you can just refer this form. Whether the entries is A11, A12, A13, and so on. Okay, so this is the A. This is the Aij. Okay, and then multiply with its cofactor. So the entries itself multiply its cofactor. Right? So you just need to choose any rows or any columns. So we continue with the example to be more detailed. So we're going to start with the example 9. Right? Example 9. You are given the matrix A, which is the element consists of 2, 3, 5, 1, 0, 2, 2, 1, 1. Find the minor of 1, 1. So the minor 1, 1 basically is the determinant of 2 by 2 matrix after deletes its row and its columns. So How are we going to delete the rows and the columns? So just refer on the question itself. So if the question asks for the M11, means that you need to delete the first row. The first row you need to delete and delete the first column. So now we can notice the remaining entries here is just only 4, which will form the 2 by 2 matrix. Since the minor itself is a determinant, so just put the notation for the determinant, which is determinant of 0 to 1, 1. And then you just need to calculate. Calculate by using AD minus BC. So it means that 0 times 1 minus 2 times 1. That will give you negative 2. And the same thing goes for M23. So I need to delete it first. Okay, M23 means that you have to delete the second row and the third column. So just delete and copy down the remaining elements or the entries, and then you just need to calculate. So 2 times 1 minus 3 times 2. Right, that will give you negative 4. And lastly, the minor of 3,1. The minor of 3,1 means that you need to delete the third row and the first column. So the remaining element is 3502. So just calculate and you will get 6. Okay, we're done for the first part. And we continue for the B. For the B, so question asks for the cofactor of 1, 1. Cofactor of 1, 1 is equals to, so you have to remember that the cofactor itself is the formula of negative 1 multiply negative 1 to the power of I, negative 1 to the power of I plus j multiply with minor. So C11 is equals to negative 1 to the power 1 plus 1. Because the value of I is 1, the value of j is 1. Multiply with minor. Okay, just assuming that, we haven't calculated for the minor 1, 1. So you just need to calculate here. The minor for 1, 1. So the minor 1, 1 is delete the first row and the first column. That will give you 0 to 1, 1, which is the same with what we have done before this. It's the same with what we have done before this. But I repeat the process by assuming that we haven't calculated for the minor. But in case if the question already asks for the minor, you can just copy down the answer that you get, which is negative 2. Just copy down and then you just multiply with the negative 1 to the power 1 plus 1. Okay, you can just skip this process. You can just skip this process if you already got the value for this part. But for this, I'll just repeat the same process. So negative 1 to the power 1 plus 1. So means that negative 1 to the power of 2. That will give you positive 1. That will give you positive 1. So positive 1 multiply with negative 2 will give you negative 2. Right, so C23. So C23 is equals to negative 1 to the power of 2 plus 3 with its minor. So minor, after you delete the second row and the third column, which is the same with what we have done before this. Okay, just copy down here. And you will get negative 1 to the power of 5 multiplied with negative 4. Okay, how you get negative 4? I just copy down from the previous part. So negative 1 to the power of 5, that will give you negative 1. Negative 1 multiplied with negative 4 will give you 4 as a final answer. So lastly, for the C31 is negative 1 to the power of 3 plus 1. The minor itself is 3502. So negative 1 to the power of 4 will give you positive 1. So multiply with negative 1 to the power of 4 multiply with 6. That will give you 6. Okay, we're done for the cofactor. Right, so continue to the determinant of A. So lastly, after we find out the minor cofactor, we find out the determinant of A. So the question already specific which expansion, so you need to use the expansion of the first row. So when it comes to the first row, means that okay, when it's come to the first row, means that we need to focus on these entries. This is the first row. Okay, so basically to find the determinant of A, determinant of A is the summation of multiplication entries with its cofactor. So means that since this is the expansion of the first row, means that the formula here is 1, 1, the element itself, multiply with its cofactor. So A11 multiply with C11 plus, okay, continue with the next entries, which is A12 multiply with C12 and plus A13 multiply with C13. Alright, and then we continue with substitute the correct, right, substitute with the correct value. Okay, but before that, there is something that we need to highlight here, which is for the cofactor. Just focusing on the cofactor, this cofactor formula. Okay, you need to understand that this part we call it as this part is known as a sign of cofactor. Sign of cofactor. So what is meant by sign of cofactor? So sign of cofactor here. So every single substitution of -1 to the power of I plus j, that will give you the alternate value between +1 and -1. So we can summarize this sign of cofactor. We can summarize the sign of cofactor as like this. The sign of cofactor, we're going to start with positive. Okay, why we start with positive? So the reason we start with positive, because of the entries itself. The first entry is for the first row and the first column. So if the entries is the first row and the first column, means that the -1 will be calculated for the -1 to the power of 1 plus 1. That will give you -1 to the power of 2. So -1 to the power of 2, which equals to positive 1s. So when +1 is multiplied with another value, you can just get rid of the 1 itself. So you're just focusing on the notation, whether the sign itself, whether it's positive or negative. So the next part, the next entries, the sign of cofactor of the next entries would be negative. So why this is a negative value? Because of the location of the entries itself. So since this is the location of A12, so what happened when we calculate for the -1 to the power of 1 plus 2, that will give you -1 to the power of 3, which is -1. So they will give you negative. So basically, if you calculate all of this sign of cofactor, you will get the alternate sign, which is positive, negative, positive, negative, positive, negative, positive, negative, positive. So as a summarize, the cofactor is actually a positive of M11, negative of M12. Sorry, okay, I repeat. So the summary for the cofactor, since the cofactor is multiplication between minor with the sign of cofactor, so the summary itself is actually equals to positive of M11, negative of M12, positive of M13, negative of M21, positive of M22, and so on. So back to the question that we want to solve it just now, which is the determinant of A. So since we're focusing on the first row, so A11, so just copy down here. So A11 is just A11. So C11, so how to get the C11? So C11 is equals to positive M11. So it's equals to M11 plus with A12. So A12 multiply with C12. So C12 is equals to negative M12. Is equals to negative of M12 plus A13 is multiply with C13. So C13 is equals to positive M13, which is A11 times M11 is minus A12 M12 plus A13 M13. So this is the conclusion for finding the determinant of A, but we haven't finished yet. We haven't calculated. It's just the expansion of the formula. So how to calculate it? So determinant of A is equals to, since it's equals to A11. So A11 is the entries for the first entry. So A11 is 2. This is the A11. This is the A11. This is the A12. This is the A13. Right? So that means 2 will be multiplied with the minor for 11. So for the minor 11, you have to delete the first row and the first column. Delete the first row and the first column. So that will give you the remaining elements here. So the remaining elements here is 0 to 11. Right? Minus with A12. So A12 is 3. It's 3. Multiply with the minor of 12. So multiply with minor 12. Multiply with minor 12. You have to delete. You have to delete the first row, second column. So the remaining elements here is 1, 2, 2, 1. So 1, 2, 2, 1. And repeat the same process. Repeat the same process. And lastly, you need to calculate. So calculate using the AD minus BC. So 0 minus 2 minus 3, 1 minus 4, plus 5, 1 minus 0. So you will get 10 as a final answer. Alright, so continue with D. So for D, the question asks for determinant of A, the same with the previous part. But this one using the expansion of the third column. So when it comes to the third column means that the entries that involve here is A13, A23, A33. So this is the third column. So determinant of A is equals to the entries multiplied with its cofactor. So it means that A13 multiplied with C13 plus A23 multiplied with C23 plus A33 multiplied with C33. Okay, so now focusing on the cofactor. So A13 multiply with cofactor of 13. So cofactor of 13, the sign of cofactor of 13 is positive. So this one is multiplied with positive of 13. Okay, if you forgot the sign of cofactor, you can just the simple way that you can do is you just need to add this value. just need to add this value. If the addition of this value we give you the even power, even number, so means that it will give you the positive sign. If the summation of this one, we give you the negative, we give you the odd number, so means that we give you the negative sign. It's this more simple way. So this one plus with A23 multiply with negative of M23 plus A33 multiply with positive of M33. So it's equivalent to A13 minus 13 minus A23 minus 23 plus A33 minus 33. So, and we continue with the substitute the correct value. So A13, just refer to the given matrix. So A13 is equals to 5 multiply with the minor of 13, which is you need to delete the first row and the third column, that will give you 1 0 2 1 minus A23 is 2, the element for the entry is 2, multiply with its minor 2 3 2 1 plus A33 is 1 multiply with minor 2 3 1 0. So if you calculate all these things, so you get 10. You are supposed to get the same value even you are using the different expansion, different row or different column of expansions. Okay, we're done for the finding of determinant. Okay, continue with the example 10. Example 10, you are given a matrix A and the question asks to find the cofactor of matrix A. So cofactor of matrix A is a consists of Cij. Okay, all of this element consists of Cij, which is before this I already give you the summary, which is positive M11, negative M12, positive M13, and so on. Okay, it's the same with this one. It's the same with this one. So we are going to use this to answer of this question. So just make the big bracket. Just make the big bracket. The big bracket, which is positive of minor, negative of minor, positive of minor. You just need to form the template first. Negative of minor, positive of minor, negative of minor, and so on. Okay, so we need to fill in the template that we have done. So the first template here is for the minor 1 1. So for this part, to fit in the entries for this part, you have to delete the first row and the first column. So delete the first row, and the first column, and then you just copy down all the remaining elements. So we have 4 5 4 1 4. Right, so next for this part, you have to delete the first row and the second column. Just copy down the remaining element and repeat, and you need to repeat the same process for all the 9th element here. Okay, so this is the remaining the entries that you need to fill in with the template that we have done. Okay, and we are going to continue with the calculations. So you have to calculate each of the single minors that we have done. You have to calculate by using AD minus BC. So each of this you need to multiply AD multiply with minus with B multiply with C. So after you have done all the calculation, you are supposed to get this cofactor of matrix A. So we're done for the first part. Alright, and then we are going to continue with the last part, find the determinant of matrix A. So you can choose any rows or any columns. So let's say we choose the first row. So determinant of A is equals to A11, C11. Okay, or you can just directly calculate. So A1, I think I will write it first. A11, C11, A12, C12, A13, C13. So equals to A11. So what we have for A11? A11 is 2. So 2 multiplied with its cofactor, which is 5, 4, 1, 4, minus with 2, which is cofactor itself is 1, 4, 3, 4, plus 3 times 1, 5, 3, 1. So you have to calculate all of these things, so it gives you 6 as the final answer. Okay, so we move to the properties of determinants. There are a few properties that you can use to find out determinant without without using the previous part that we have discussed. Okay, so we go through the properties listed here. So the first properties is if any row or column of a matrix A is 0, then automatically the determinant of A equals to 0. Without you need to find out, without using the expansion of row or column. Means that you don't have to find out the entries multiplied with the cofactor. You can directly write down the answer for the determinant itself. Okay, so for example, if you are given this matrix, which is 1, 4, 6, 0, 0, 0. So this row, all of the entry for this row consists of entries 0. So means that the determinant of this matrix is automatically 0. The same thing for the other example, which is the second column. The second column consists of entries 0. So the determinant itself is equals to 0. So you don't have to calculate it. So the second property is that you can apply. If you notice, if any rows or column of a matrix A is multiplied by a non-zero K to produce a matrix B, then the determinant of B is equals to that constant multiplied with determinant of A. For example, if you are given a matrix which is 1, -1, -3, 2, -1, -4, 1, 1, -1, which is its determinant is -2, and you are given another matrix which is you need to find out its determinant, and if you notice any rows or any column are multiplied with a non-zero. So for example, you can see here this row is multiplication of a constant 2 with this matrix. So you can just skip all the process of finding the determinant by using the expansion of row or columns. So how we are going to use these properties? You just need to follow these properties, which is the determinant is equals to the value of K. So the value of K here is 2 because of the transformation between the previous matrix to the transformation between these two matrix is by multiplication of constant 2 to the row number 3. So this is the transformation. So focusing on the constant here, which is 2. So to find out the determinant, you just need to multiply 2 with its determinant from the previous matrix, which is -2. So you will get -4 as a final answer for that determinant. So for the next properties, state that if a square matrix A has one or a column that is a scalar multiple of another row, then the determinant is equals to 0. So if you notice any row or any columns on that matrix is a scalar multiple. It's a multiple of another row or another column. So the determinant itself is equals to 0. So for example, the first matrix here, these two column, you can notice here, this column is actually multiple 2 of the second column. If you multiply each of this entry with 2, you will get 6, 14 and 8. So if that case, the determinant of the matrix is 0. Okay, for the next example, you can see here, the first row and the third row is a multiple of a scalar. There is a scalar multiple of one another. So means that the determinant itself is equals to 0. Right? So the next property is, if two rows or column of a matrix A are interchanged to produce a matrix, then what happened to the determinant itself is you just need to multiply with negative to the determinant itself. So means that if there are interchanging between rows and column, so you have to multiply with negative 1. So for example, if you are given this matrix, which is determinant is negative 2, so you have to find out another determinant, you have to find out determinant of another matrix. So, and if you notice that it's follow these properties, which is for this one you can notice that there is interchanging between the second row, the second column and the third column. Okay, interchanging between second column and third column. So for that case, what happened to the determinant? So the original determinant need to be multiplied with negative. So that will give you 2. Okay, next properties is determinant of A transpose is equal to determinant of its original matrix. So if you transpose a matrix and you need to find out its determinant, so it's just the same, which is determinant. Since for the example, if you have determinant of matrix A is equal to, so means that determinant of A transpose is equals to 2. And the last properties that you can apply is for square matrices A and B of equal, so the determinant of AB is equals to determinant of A and determinant of B. So for example, so what is mean by these properties? Okay, means that you don't have to, you can skip this process. Okay, you can skip the process of multiply. You don't have to multiply of AB. Okay, for example, if you are given a matrix A, matrix B, okay, you are given the matrix A and the matrix B, and you already calculate the matrix determinant of A, which is 1, determinant of B is equals to 4, and the question asks for finding determinant of AB. So you just skip this process. You don't have to multiply these two things. Okay, so because our target is to find out the determinant of AB. So by using these properties, so determinant of AB is equals to determinant of A multiply with determinant of B. So you just need multiply this to value, which is 1 multiply with negative 4. So that will give you negative 4. So we will discuss example 11. So example 11, you are given a matrix with its determinant, which is 77. So evaluate the following using the properties. So the question itself already stated that you need to use the properties of determinant. So you cannot use this method. You cannot use this method. Okay, you cannot manually calculate for the determinant. You have to use the properties. Right, so how are you going to do that? For this question, you have to observe what's the interchanging that happened from the original metric to the given metric. So for the question A, if we look at the entries here, you can see here that the 257, okay, the elements for 257, it's originally comes from columns. The row is actually comes from the column. 1, -1, 5, it comes from the second column. The third row is come from the third column. So means that what happened here is, okay, what happened here is there is a transpose process happen here. So it means that if you transpose back, you will get 257, 1, -1, 5, 4, 3, 6. So this metric, so means that this metric is equals of 214, 5, -1, 3, 7, 5, 6 transpose. So if you can see here, 214, 5, -1, 3, 7, 5, 6 is equivalent from this question. So since the determinant of this metric is 77, so by applying one of the properties that we have discussed here, which is the properties that we need to use here is this one. So since the determinant of A transpose is equals to A, so what you get here, so determinant of 214 transpose is equal to determinant of 214, 5, -1, 3, 7, 5, 6, which is equals to 77. It's just the same. Alright, so B. So for B, okay, you are given 2, 4, 1, 5, 3, -1, 7, 6, 5. So if you go through all of this entry and you compare with what you have given from the question, okay, you can notice here, okay, what's the transformation that happened is you can see that there is some interchanging. There is some interchanging between the second column and the third column. Okay, so if you change it back, you will get 2, 5, 7. You interchange between the second column to the third column. You get 1, -1, 5, 4, 3, 6. If you interchange row or column, you have to put a negative sign here because of these properties. Right? Because of these properties. These properties say that if there is some interchanging between row or between columns, you have to put a negative sign. So the negative sign, so is equals to -77. Okay, we done. So last example. Okay, last example. Take a look for all the entries. So what we can see here, if you compare C with the questions, we can see here there is interchanging between the second row and the third row. So if you interchange this entries, second and third row, so 5, -1, 3, 7, 5, 6, it will become the same with the question, the header of the question. It will be the same by this one. But you have to remember that if there is some interchanging between rows and columns, you have to put a negative sign. So it's equals to -77. So we're done.